Page 3 of Transformations Addendum. So we're going to continue where we left off on page 2. On page 2, we found some characteristics of two rational functions, 2x plus 3 over x plus 1 right here, and 2x minus 1 over 3 minus x. We rewrote these functions in this form here, which makes it a little bit easier to see. We'll circle this one. Which makes it a little bit easier to see the characteristics to graph it. So why don't we start graphing. First thing you always want to graph when you have a rational function are the asymptotes. In this case, let's find the asymptotes. We have x equals -1 and y equals 2 on this one, and on this one we have x equals 3 and y equals -2. Let's do our asymptotes in blue. So for this one, x equals -1 is a vertical asymptote located at x equals -1. So there it is right there. And the horizontal asymptote is the horizontal line located at y equals 2. Okay, let's do the other one. The other one has a horizontal asymptote at y equals -2. Y equals -2. And the vertical asymptote is at x equals 3. Okay. Now let's go back and we are going to graph the rational function of a. The rational function is a positive rational function, and there is a vertical stretch of 1, which it's not vertical stretched at all. So the way you would write that, I'm gonna do it in red. And it's a positive function, so basically the positive functions go in these two quadrants. So one of the points is going to be the 1, 1 point relative to the asymptote. You're going to do one of those in each of the quadrants that have the hyperbola in it. And okay, so it looks kind of like that. And then one thing it asks us to describe the behavior of the graph near the asymptotes. So it's a lot easier to do that once you sketch the graph. So let's see. When x goes to infinity, when x goes to positive infinity, what happens with the graph? Well, the y approaches the value 2 from the top. When x goes to negative infinity, then y approaches 2 from the bottom. So you see it's approaching from the bottom here, it's approaching from the top here. Okay? All right. Then what about the vertical asymptote? So the vertical asymptote, when x approaches 2 from the left, y approaches negative infinity, right? It's going whoop. And when x approaches 2 from the right, y approaches positive infinity. Okay. And let's graph the other one. So this one here has a vertical stretch of 5. Okay, so and the other thing is that it's a negative rational function. So that means instead of being in the first and the fourth quadrant, it's in the second and the fourth quadrant. What did I say? The first, instead of being in the first and the third quadrant, it's in the second and the fourth quadrant. So one quadrant is going to be as here, and one quadrant is going to be as here, and it's going to be stretched 5. So instead of going through this point here at 1, 1, it's going to go through 1, 2, 3, 4, 5. It's going to go through that one. It's going to go through 1, 2, 3, 4, 5. It's going to go through that one. Now I'm going to draw my hyperbola through those points. Okay. And on the other side, it'll go through the reflected points. So like 1 here, 1, 2, 3, 4, 5, 1 here. Okay? All right, and then when we describe the asymptotes, we will say as x approaches in positive infinity, y approaches -2 from the bottom, and as x approaches 3 from the right, y approaches -infinity, and as x approaches 3 from the left, y approaches positive infinity, and here as x approaches -infinity, y approaches -2 from the top. Okay? All right. So those are our functions from last page. Number 5. In order to remove noxious weeds from her property, Helga sprays with a weedicide. The chemical is slow to act, and the number of weeds per hectare remaining after T days is modeled with this function. How many weeds per hectare were alive before the spraying? Okay, so remember that the way you figure out the initial value of a function is you put t equals 0. So A is basically saying, okay, substitute t equals 0 and see what you get. So if I put t equals 0, I'm going to have n equals 20 plus 100 divided by 0 plus 2, which is 2. So 20 plus 50, right? So it would be 70 is the number of weeds per hectare that were alive before the spraying. How many weeds will be alive after 8 days? So that would be t equals 8. So let's figure it out. N equals 20 plus 100 over 8 plus 2, which is 10. So 20 plus 10 is 30. And how long will it take for the number of weeds still alive to be 40 per hectare? So in this case, what it's saying is, okay, the number of weeds, which is n, is going to be 40. Tell me what t would be in that case. So, subtract 20 from both sides. Multiply both sides by t plus 2. Divide both sides by 20. Equals 5. So t plus 2 equals 5. Subtract 2 from both sides, we get t equals 5 minus 2, which is 3. So the answer to C is t equals 3. So in 3 days, there will be 40 weeds alive. Sketch the graph of n against t. According to the model, is the spraying going to eradicate all the weeds? Okay, so let's draw the function. Now, what's the horizontal asymptote? The horizontal asymptote would be 20, right? And the vertical asymptote looks like it would be -2. Okay, so let's draw those. Horizontal asymptote is 20. So let's say that this value here is 20, and this value here is 100. This is n. And the t value, it says that 2 is the, -2 is the asymptote, right? I'm just going to, so this is -2, and this is 0. And so this is our asymptote. And the axis is, the x-axis is here, and the y-axis is here. So actually, let me move my marks to here. Okay. And, okay, so let's mark some of the points that we found. For example, t equals 0, the end point was 70, which was here. And t equals 8, the end point was 30. 830. And the asymptote is t equals -2, right? And the asymptote, the horizontal asymptote, is going to be 20. Okay. So there's the sketch. According to the model, is the spraying going to eradicate all the weeds? Meaning, is it going to go down to 0? And it doesn't look like it will, because the horizontal asymptote is 20, so it's never going to go below 20. So it's you could say the horizontal asymptote is 20, so n will not reach even 20, let alone 0. Okay, and that is the end of page 3.